Thank you very much. It's actually less philosophical than it sounds. So the way I wrote it, it sounded very philosophical, but my research is more based on results and experiments, and I draw conclusions out of it. And the title that I wrote when I submitted the article was Soft Evolutionary Robotics, which is what I work with, Evolutionary Robotics, although now I'm adding a new twist, which is Bayesian optimization, and I'm going to present today. And I adapt both morphology and control to the world around us. So as we walk, we humans, we walk around and we have disturbances, and sometimes I walk with a different shoe, in sandals, without shoes, and all of these things, they change the way that we're supposed to walk. If we're working with a robot, we have to have a ZMP doing some static locomotion, and having or not having shoes is going to drastically affect the behavior of the robot. But we humans, we know how to adapt to these, so we should change our control to adapt to these, because the morphology is changing. But also, we can do the other way around. As we grow, we learn how to use one specific kind of control to move our body. Let's say when we are babies and we learn how to walk. And 1 week later, we are 1 centimeter taller. So the morphology also changes constantly in our bodies. So learning how to play with these two parameters. In physics, they talk about space and time, and they make the continuum. To me, this is the continuum of robotics, the morphology and the control. One is these two are intertwined, and understanding how they interact is the secret. And so I try to reach intelligence by moving and walking around in the world, not in a philosophical way, but literally with a robot that walks or hops. So, as I said before, 4.5 trillion. I don't know if you were here in the morning, but AI is very advanced, in my view. AI is very advanced currently, especially with the computational power that we have with deep learning, with convolutional neural networks. And having these in machines, in robots interacting with the world is the key, is the problem. And I hope it's not my computer. So, and the problem is that robots came from an industrial background, and they are too hard to interact with people. And no matter what kind of computation you use, you can make it faster and faster, and reaching gigahertz of iteration between sampling time. But there is always a